Hello, and welcome back to Let's Data Science. Today we are diving into something truly game-changing for data scientists and machine learning engineers. NVIDIA just released cuml 25.02 with a feature that could dramatically speed up your ML workflow, zero code change acceleration for scikit-learn, UMAP, and HDBSCAN. Imagine getting up to 200 times faster performance on your existing scikit-learn code with just a single line of code. Sounds too good to be true. Let's put it to test on a Google Colab's T4 GPU and see how it performs in the real world. So what is cuml zero code change? Well, NVIDIA's latest release allows you to accelerate your existing scikit-learn workflow without changing a single line of your model code. All you need to do is add this one magic line before your imports. That's it. From there, you can keep using the same scikit-learn API you're already familiar with, but behind the scenes, NVIDIA's CUDA-powered GPU algorithm will accelerate compatible operations. According to NVIDIA, this can deliver up to 50 times speedups for scikit-learn algorithm and even more dramatic improvements on UMAP and HDBSCAN, up to 60 times and 175 times respectively. But those numbers were measured on their high-end H100 GPUs. Let's see what kind of performance we get on a Colab free T4 GPU. There's one important quirk I discovered when testing this. Once you load your cuml accelerator extension, it keeps intercepting scikit-learn imports until you restart the runtime. There is no documented way to unload the cuml accelerator once it's loaded. For accurate testing, I had to start with a fresh runtime session, run both CPU and GPU version on a single algorithm in sequence, CPU first, GPU later. Restart the runtime completely, repeat for the next algorithm. This happens because once cuml acceleration is loaded, it affects all subsequent code in the session. So for each algorithm like random forest, HDBSCAN, and UMAP, I needed a fresh runtime to get accurate CPU baseline measurement before enabling GPU acceleration. If you're trying this yourself, I would suggest you create a separate script for each test to keep things clean and organized. So first I tested with random forest on a full cover type dataset. That's about 580,000 samples with 54 features. Here's what happened. The CPU time was 87.60 seconds and the GPU time with cuml was 8.79 seconds. That's almost 10 times faster. Interestingly, prediction speed was slightly slower on GPU for small batches, but training saw a massive improvement. One thing to note, the accuracy was slightly different between implementations. The CPU version had 89.2% accuracy while this GPU version reached 73.9%. This is expected since cuml uses different implementation strategies to take advantage of GPU parallelism. Next was HDBSCAN clustering on a synthetic dataset with 100,000 samples and 100 features. The result here were absolutely mind-blowing. You read that right. What took over 18 minutes, 1093 seconds on CPU finished in just 5 seconds on GPU. That's a staggering 216 times speed up. Even better than NVIDIA's own benchmarks. And the silhouette score was identical between implementations, showing the clustering quality remained the same. Finally, I tested UMAP on 50,000 MNIST images with 784 dimensions each. The CPU time was 71.31 seconds and the GPU time with cuml was 5.39 seconds, a solid 13 times speed up for dimensionality reduction, which is impressive on Colab's T4 GPU. So when should you use this? This acceleration is perfect for large datasets that take forever to process, hyperparameter tuning where you need to train your many models, complex algorithms like HDBSCAN that are computationally intensive, any ML workflow where you're waiting around for training to finish. The best part, it's already pre-installed on Google Colab, so you can try it right now without any setup. Just add that one line of code before your scikit-learn imports. On just a Colab's T4 GPU, imagine what you could achieve on a more powerful hardware, and all of this without changing a single line of your model code. If you're doing any kind of machine learning with scikit-learn, UMAP, or HDBSCAN, you owe it to yourself to give this a try. Your productivity and patience will thank you. If you found this useful, don't forget to like this video and subscribe to Let's Data Science for more content like this. Please read the complete article to find more information and detailed codes on Let's Data Science. Stay connected and keep accelerating your data science journey. See you in the next video.